Welcome back to our lecture series in control system. So in today's class, we are discussing about the role of Laplace transformation in control system. In last class, we were discussing about standard representation of second order system. A second order system, naturally, it is having a undamped oscillation behavior, and based on the damping, we can classify it as underdamped, overdamped, and critically damped systems. So, it may have imaginary roots, it may have real roots. Such possibilities are there based on the condition of damping. So, if you are having any doubt on the basic structure or basic classification of second order system, please refer lecture number 14 before starting this video, because after learning the Laplace transform well, we will directly move to the problems based on second order system. So, the basic knowledge about the structure of a second order system and the standard representation of second order system is well explained in our last video. Okay. So, now why Laplace transform is needed? In some previous lectures also, we have applied some direct Laplace transform techniques for converting a differential equation into frequency domain. What is the basic procedure for designing a mechanical system? For designing the mathematical model of mechanical system, in first step we will apply some basic equation, basic knowledge about the applied force and input output relations, and from that normally we will get a first order differential equation or a second order differential equation. Generally it is an ordinary differential equation, and for easily solving that, we are converting that differential equation from time domain to frequency domain. For that we are using Laplace transform. For that conversion we are using Laplace transform. Okay. And by using Laplace transform, we can convert that into frequency domain, and now we will get a transfer function in S domain or frequency domain. It may be like some 1 by s square plus 5s plus 6, like that. Some transfer function will be obtained in frequency domain, and if we want to find its response, we have to assume some input. Transfer function is C of s by R of s, that is given. Then we will find C of s, that is equal to transfer function into R of s. We will cross multiply R of s, and we will assume some input like step input. If it is step input, R of s is 1 by s. Okay, like that. So, after obtaining the C of s, we want to convert it back to time domain for obtaining the time response. C of s is response in frequency domain. If we want time response, we want to convert that back to time domain. For that conversion, we need inverse Laplace transform. So basically, Laplace transform and inverse Laplace transform is very, very important for control system problems. So before going to the before going into the details of problems related to second order system, it is very compulsory to have some basic knowledge in Laplace transform and inverse Laplace transform. So in this video, that is lecture number 15, we are dealing about the basic equations and basic transformation rules in Laplace transform, and in next video we will be discussing about partial fraction in detail. Why partial fraction is needed? For finding inverse Laplace transform, partial fraction is very, very important. Okay, if you have any doubt in that, we will discuss those things very detailed in upcoming videos. And if you are very well, if you are very good in your mathematic basics in Laplace transform, you can skip these videos also, lecture number 15 and 16. Otherwise, it will be a repetition for you. But generally, I recommend all of you to go through this lecture number 15 and 16 for having a good confidence in the Laplace transform. Okay, so now we can move into the topics. Now, what is Laplace transform? Laplace transform converts time domain to complex domain known as frequency domain. uh, frequency domain is its specific name that we are given in all calculations, like in electrical circuits. In all such calculations, we are generally calling it as frequency domain. And it's a complex domain. Complex domain means it may have real and imaginary parts. So we are also calling that domain as S domain. So Laplace transform is nothing but we are converting some differential equation. Differential equation, it is basically in time domain. It will be variable with respect to time. We are converting that to a new arbitrary domain. In that domain we are having a real term and imaginary term. So that's why we are calling that domain as a complex domain, and its name is frequency domain or S domain. What is S? S is an arbitrary thing. It contains both real term and imaginary term. So S is a complex variable. In time domain, it is depending purely on time. Time, if it is voltage or current, whatever, its value is varying with respect to time. That is a single that's a single dependent condition. But here it is depending on two things. One may be a real thing and the other may be an imaginary thing. That is the difference. So that domain is known as S domain. S is nothing but sigma plus j omega. Sigma is the real term, j omega is the imaginary term. So the Laplace transform of a function f of t is defined as, what is f of t? Function of time. So now it is in time domain. Now we want to convert that to frequency domain. So what we will call for that term frequency domain? Function of frequency domain or function of S. S is nothing but a complex variable contains sigma plus omega, j omega. So we want to convert f of t from time domain to frequency domain. So f of S is nothing but Laplace transform of f of t. You can see here f of S is nothing but f of S is equal to Laplace transform of f of t, and the equation is integral 0 to infinity f of t e raised to minus st dt. So you are just integrating the time domain equation from with a limit of 0 to infinity and f of t into e raised to minus st. That is very important, where s is nothing but sigma plus j omega. S is the complex term. So it is a mathematical equation. Let us see how we can find the Laplace transform of a simple function. So I am taking a constant k. It may be 1, 2, 5, 10, 1000, whatever it may be, a constant k. How we can find the Laplace transform of that constant L of k? L of k is nothing but 0 to infinity k into e raised to minus st dt. Okay. So now we are going to integrating k into e raised to minus st. K is a constant, nothing will happen. E raised to minus st, where as t is the variable, then e raised to minus st, its integral will be e raised to minus st by minus s. So k into e raised to minus st by minus s, that is the thing we got after integration. Then we have to apply the limits 0 to minus infinity. So upper limit is minus infinity, lower limit is 0. Then it will be 0 minus k by minus s, that is nothing but k by s. So this is the way how we can find the Laplace transform of any function. Let it be k, let it be some sin omega t, cos omega t, whatever we can do. But for saving time, we have to by heart these expressions. This is the way how we can find Laplace transform. But for some 8 or 10 standard functions, you have to by heart time domain expression and frequency domain expression. For example, for k in time domain, its frequency domain is k by s. If k is equal to 1, the value of constant is 1, that is 1 by s. Value of constant is 2, that is 2 by s, like that. So we can by heart Laplace transform of some important functions. If function is k, Laplace function is k by s. I will No, no much explanations are required for these things. If you want, if somebody want how this came, e raised to at, Laplace transform of e raised to at is 1 by s minus a. How we got this? If you are having any doubt, you can refer your basic mathematics textbooks. But I personally recommend for by hearting these things, because this will be that much helpful for solving all problems, not only in networks, in control system, and in many of the upcoming subjects. You should have the basic knowledge about Laplace transform, and it should be by hearted the basic functions. So third one, e raised to at. E raised to at is 1 by s minus a. You should be very careful that e raised to at, if here it is plus, here it will be minus 1 by s minus a. And for e raised to minus at, it is 1 by s plus a. If it is minus at, then the Laplace transform function will be 1 by s plus a, minus plus minus. That will be somewhat confusing, so be careful. So next one, 5, sin omega t, omega by s square plus omega square. Okay, cos omega t, that's the difference. In sin, the numerator was omega, but in cos, the numerator is s. So cos omega t, s by omega s square plus omega square. If these things are, if 5 and 6 are clear, 7 and 8 are somewhat very close to these 5 and 6. In that, hyperbolic functions are explained. The sin h omega t, sin h omega t. Everything is exactly same to sin omega t, but the sign plus or minus in the numerator, in the denominator will change. For sin omega t, it is omega by s square plus omega square. For sin h omega t, it is omega by s square minus omega square. Wherever h is coming, you have to replace the plus in basic equation with minus. So what was cos omega t? S by omega s square plus omega square. S by s square plus omega square. So what will be cos h omega t? S by s square minus omega square. Very simple. Now some properties that will help you in some problems, and it is very simple and useful. First one, linearity. L of f1 of t. f1 of t is first function with respect to time. That is f1 of s. We are converting, or we are taking the Laplace transform of f1 of t. It is f1 of s. And Laplace transform of f2 of t is f2 of s. Then a1 into f1 of t plus b into f2 of t. We are multiplying those time domain equation with some constant and adding both. Then Laplace of that thing should be a into f1 of s plus b into f2 of s. That is the condition for linearity. Now, frequency shifting theorem. Frequency shifting theorem means in f of s you are applying some shifting plus or minus. Time shifting theorem means in time domain you are applying some plus or minus values. Shifting means you are adding some plus or minus constants. So frequency shifting means if Laplace transform of f of t is f of s, for any such theorem, this will be the first thing. Laplace transform of f of t. This is L of f of t is f of s, then L of e raised to minus at f of t is equal to f of s plus a. This is the shifting in frequency, f of s plus a. So if frequency is shifted by plus a, you have to multiply time domain equation with e raised to minus at. So e raised to minus at into f of t is equal to f of s plus a. For example, if f of t is equal to 1, please be very careful. If f of t is equal to 1, what is f of s? F of t is equal to 1, what is f of s? 1 by s. Laplace transform of 1 is 1 by s. Okay. Then I am asking you what may be e raised to minus 2t into 1. Laplace transform of e raised to minus 2t into 1. Please do it in a paper if you are having some confusions. You already know f of t. If f of t is 1, f of s is 1 by s. Then I am asking you Laplace transform of e raised to minus 2t into 1. From the equation we know that e raised to minus 2t into f of t is 1. That should be f of s plus a. What is f of s? 1 by s. So 1 by s plus a. In my example, what is a? I already told you that e raised to minus 2t. So a is equal to minus 2. A is equal to 2. So f of s plus a is equal to 1 by s plus 2. On the other hand, if I am asking you to find e raised to 2t, Laplace transform of e raised to 2t into 1. Please write in the paper. Laplace transform of e raised to 2t into 1. Then it will be f of s minus a. F of s minus a. Then that is equal to 1 by s minus 2. Like that. Now, next, time shifting theorem. Time shifting theorem means if L of ft is f of s, this is common for all the theorems, then L of f of t minus a, here we are shifting in time, that is equal to e raised to minus as into f of s. E raised to minus as into f of s. Okay, you can validate those things easily like last example. Then it is multiplication by t. If Laplace transform of f of t is equal to f of s, then multiplication by t means I am asking you what is Laplace transform of t into f of t. You already know Laplace transform of f of t is equal to f of s. Okay. Like Laplace transform of 1 is equal to 1 by s. What is Laplace transform of t into 1? What is Laplace transform of t into 1? As per this equation, Laplace transform of t into 1 is minus of d by ds of f of s. What is f of s? F of t is basically 1. So f of s is equal to 1 by s. So d by ds of 1 by s. What is 1 by minus 1 by s square into minus is here outside. So it will be 1 by s square. So Laplace transform of t into 1 is 1 by s square. So it is easily we can find by using this theorem. So if Laplace transform of f of t is f of s, that you already know that f of t may 1 sin omega t, cos omega t, whatever it may be, you know it's f of s. Then you are asked to find Laplace transform of t into f of t. Then you just take the basic f of s and differentiate it with respect to s and put a minus sign in front of that. You will get the answer. Next, division by t. Division by t means the basic thing is here common. If L of f of t is equal to f of s, then division by t. We are dividing that f of t by some t. Then for finding that answer, you have to integrate the basic f of s. If f of t is 1, f of s is equal to 1 by s. Now I am asking you to find Laplace transform of f of t by t, that is 1 by t. Then what you have to do? You have to integrate the basic f of s. What is basic f of s? 1 by s with the limit s to infinity. Then you will get the answer. Please check these things. The examples are there in your textbooks. I am not taking that much time for these theorems and its proof and all, but it will be helpful in some problems. Next, time differentiation theorem. Here, in last case, we are divided time and we are multiplied time in time domain. Now we are applying some differentiation in time domain. So here also basic thing is common. If Laplace transform of f of t is f of s, then Laplace transform of f dash t, what is f dash t? Differential of f of t. Laplace transform of f dash t is nothing but s into f of s minus f of 0. So this is very useful. Actually, L of f double dash t, f triple dash t, because double integral, double differential, all these things we can do. But here we are finding f dash t. Okay. Okay, so let us take an example. Find Laplace transform of minus a into e raised to minus a t. So, if you are seeing that problem, you should be able to understand that all these things inside the bracket minus a into e raised to minus a t comes under this criteria, f dash of t. What is f of t? Please take this example. If f of t is e raised to minus a t, f of t is e raised to minus a t, what is f of s? 1 by s plus a. Okay. Then what is f dash of t? F dash of t is equal to e raised to minus a t into minus a. That is the question you already got. So, already you are asked to find Laplace transform of some f dash t, and its f of t is from the question. If you can understand that, we can say its f of t is equal to e raised to minus a t. So, basic f of t for that problem is e raised to minus a t, and its basic f of s is equal to 1 by s plus a. Then L of f dash of t is, as per our basic equation, s into f of s minus f of 0. F of 0 is, put s is equal to 0 in the f of s equation. That's it. So, s into f of s. Here s into basic f of s is 1 by s plus a minus f0. f0 is in this basic f of s, put s is equal to 0. That is 1 by 0 plus a. This is the answer. So, if you are having any doubt, please revise once more. You will, basic thing is that while seeing the question, you should be able to identify that it is nothing but it comes under f dash t classification, because e raised to minus a t is f of, if e raised to minus a t is f of t, its differential is minus a into e raised to minus a t. If you have that basic knowledge, you can easily solve this problem. Now, next one, time integration theorem. In time integration theorem, you are having some integration in time domain. So, basically, if L of f of t is f of s, then you are asked to find the Laplace of integral of f of t. Integral of f of t. Then that answer will be f of s by s. In previous one, it was somewhat in form of s into f of s minus f dash 0. Now it is somewhat in the form of division, f of s by s, division. So, again, find L of e raised to a t by a. While seeing itself, you should be able to understand that if e raised to a t is, f of t, its integral will be e raised to a t by a. If e raised to a t is in f of t, its integral will be e raised to a t by a. So, while seeing the question, you should be able to understand that it is comes under this classification, integral of f of t. So, suppose L of e raised to a t is f of t, f of s is 1 by s minus a, 1 by s minus a, and e raised to a t by a is nothing but 0 to t f of t dt, and as per the basic equation, the answer will be f of s by s. Here f of s is nothing but 1 by s minus a all divided by s. That is the answer. So, these are the basic theorems that you should learn before solving some problems in Laplace transform. So I recommend all of you to by heart those shifting theorems, time multiplying, frequency multiplying, division theorems, and also by heart those standard equations like sin omega t, cos omega t, those things. And in next class, we have to take some problems on Laplace transform and Laplace inverse transform. What is Laplace inverse transform? If Laplace inverse of 1 by s is 1, Laplace of 1 is 1 by s. So Laplace inverse Laplace of 1 by s is 1. Laplace of e raised to at is 1 by s minus a. So Laplace inverse of 1 by s minus a is equal to e raised to at, like that. For that Laplace inverse transform, we should have some strong idea on partial fraction also. So in next class, we may be discussing about partial fraction. Then we should go to Laplace transform and Laplace inverse transform. And in next class, we should learn how to apply these transformation in circuits problems. Normally, you will get some differential equation first order. In case of RL and RC, it will be first order differential equation. We will convert that equation directly from time domain to frequency domain by using these equations and theorems. If it is a second order differential equation, in case of RLC, it may be a second order differential equation that may be also converted directly to time domain, from time domain to frequency domain. So this is the time to by heart all these things, and in next class we will discuss about partial fraction, and then we will do problems in the upcoming classes. So thank you.